Welcome back to Drowsy Discoveries. Tonight, we're turning our attention to the moon, Earth's oldest companion, and one of the most calming things in the night sky. Before we begin, let's take a moment to settle in. Find a comfortable position, whether you're lying down or sitting still. Let your arms fall gently to your sides. Let your shoulders drop away from your ears. Feel the weight of your body sinking into wherever you're resting right now. Take a slow, deep breath in through your nose, hold it gently, and release it through your mouth. And again, breathe in and let it go. Let your eyes close softly. Let the thoughts of your day begin to drift away like clouds passing slowly across a dark, quiet sky. There is nothing you need to do right now, nowhere you need to be. Your only job tonight is to rest. Take one more deep breath in and slowly let it go. Tonight, we're going somewhere very close and yet very far. We're going to the moon. That quiet silver light that has watched over every human who has ever lived. Every person who ever felt something in the still of the night and looked up. Over the next 2 hours, you'll drift through 100 gentle, fascinating facts about the moon. Let your body relax. Let your thoughts slow. Let the moon carry you into sleep. Fact number 1. About 4.5 billion years ago, a Mars-sized object called Theia slammed into the early Earth. The collision was so violent it vaporized rock, hurled debris into orbit, and out of that swirling chaos, the moon was born. Everything you see in the night sky tonight was once part of our own planet. Every single year, the moon drifts about 3.8 centimeters farther from Earth. That's roughly the rate your fingernails grow. It doesn't sound like much, but over billions of years, it adds up. When the moon first formed, it was about 15 times closer than it is today, and the tides it caused would have been absolutely enormous. Deep inside the moon, beneath hundreds of kilometers of rock and dust, there is a small iron core, about 300 miles across. It's surrounded by a partially molten layer, still warm from the moon's ancient volcanic past. The moon isn't just a dead rock. It has an interior that's still slowly cooling, even now. The moon takes exactly as long to rotate on its axis as it does to orbit the Earth, about 27 days. This isn't a coincidence, it's called tidal locking, and it's why we always see the same face of the moon. The Earth's gravity has been slowing the moon's spin for billions of years until these two cycles perfectly matched. The dark patches you see on the moon, the ones ancient people called the man in the moon, are ancient lava plains. Billions of years ago, the moon was geologically active, with volcanoes erupting across its surface. Molten rock flooded the low-lying craters and basins, creating vast, flat plains of dark basalt. Stand on the moon and you'd be in complete silence. There's no air to carry sound, no wind to stir the dust, no weather of any kind. The sky is black even in daylight. Without an atmosphere to scatter sunlight, you could look up and see stars at the same time as the sun, a sight no human eye ever sees on Earth. Some of the rocks brought back by Apollo astronauts are over 4 billion years old. Without plate tectonics or erosion, the Moon preserves its history perfectly. A footprint left on the lunar surface today would still be there, unchanged, millions of years from now. The Moon is essentially a museum of the early solar system. The Moon isn't as still as it seems. It experiences moonquakes, some caused by meteorite impacts, some by tidal forces from Earth's gravity, and some from deep within its interior. Apollo missions left seismometers on the surface, and they recorded the Moon ringing like a bell after impacts, vibrating for up to an hour. If you weigh 150 pounds on Earth, you'd weigh only 25 pounds on the Moon. You could jump 6 times higher. You could lift objects that would be impossible to move on Earth. Astronauts described moving on the Moon as dreamlike, a slow, bouncing lope that felt almost like flying. There are over 200 known moons orbiting planets in our solar system, and our Moon ranks 5th in size. But what makes it truly remarkable is its size relative to Earth. The Moon is about 1/4 the diameter of Earth, making it the largest moon relative to its host planet. Some astronomers consider Earth and Moon a double planet. Every time the ocean rises and falls, the Moon is pulling it. The Moon's gravity creates a bulge of water on the side of Earth closest to it, and another bulge on the opposite side. As Earth rotates through these bulges, we experience high and low tides. Without the Moon, tides would still exist, but they'd only be about 1/3 as strong. Earth is tilted at about 23.5 degrees, and that tilt is what gives us seasons. Without the Moon's gravitational stabilizing influence, scientists believe Earth's tilt could wobble dramatically over millions of years, swinging between near zero and over 80 degrees. Such swings would cause catastrophic climate changes, possibly making complex life impossible. Earth's days are getting longer, very, very slowly, but longer. The Moon's tidal friction is gradually slowing Earth's spin. In the distant past, a day on Earth was only about 6 hours long. In the far future, if the Moon is still here, a day could last over 1,000 hours. Time itself is stretching, one tiny fraction of a second per century. Some scientists believe the Moon played a crucial role in the origin of life on Earth. The strong tides it caused billions of years ago may have helped mix the chemical soup in shallow coastal waters, encouraging the complex chemistry needed for life. The Moon didn't just light our nights, it may have helped spark our existence. The Moon produces no light of its own. Every soft, silver beam of moonlight you've ever seen is sunlight that traveled 93 million miles to the Moon, bounced off its grey dust, and then traveled another 240,000 miles to reach your eyes. The Moon is actually quite dark. Its surface reflects only about 12% of the light that hits it, similar to worn asphalt. You might expect a full moon to be twice as bright as a half moon, but it's actually about 14 times brighter. This is because when the sun shines directly on the Moon, the lack of shadows makes the surface appear dramatically brighter. The geometry of light and shadow creates this surprising difference in luminosity. By pure cosmic coincidence, the Moon is about 400 times smaller than the Sun, but it's also about 400 times closer to Earth. This means that from our perspective, the Sun and Moon appear almost exactly the same size in the sky, which is why total solar eclipses are possible. The Moon can fit almost perfectly over the Sun, creating one of nature's most breathtaking spectacles. Sea turtles use moonlight to find their way from nesting beaches to the ocean. Coral reefs spawn in synchronized mass events tied to the full moon. Many nocturnal animals are more active during certain lunar phases. Even human sleep patterns show subtle variations with the lunar cycle, according to some studies, though scientists are still exploring exactly why. The far side of the moon, often mistakenly called the dark side, isn't dark at all. It receives just as much sunlight as the near side. It's simply the side that never faces Earth. It wasn't seen by human eyes until 1959, when a Soviet spacecraft flew around and photographed it. The far side looks quite different, more heavily cratered, and with fewer dark lava plains. Just as the moon pulls on Earth's oceans, it also pulls on the atmosphere, creating atmospheric tides. These effects are small compared to ocean tides, but they're measurable. The moon gently compresses and stretches the layer of air around our planet twice a day, a subtle reminder that even the sky above us is touched by the moon's quiet pull. Between 1969 and 1972, 12 Americans walked on the surface of the moon. Neil Armstrong was first. Eugene Cernan was last. All 12 described the experience in terms that go beyond ordinary language: a profound silence, an overwhelming sense of isolation, and a view of Earth hanging in the void that permanently changed how they saw everything. The Apollo missions returned 842 pounds, about 382 kilograms, of lunar rocks and soil to Earth. These samples have been studied for decades and continue to reveal secrets about the moon and the early solar system. Some rocks are kept sealed, preserved for future scientists with technologies not yet invented. When Neil Armstrong stepped onto the moon on July 20th, 1969, an estimated 600 million people watched on television, about 1/5 of the entire world's population at the time. It remains one of the most watched moments in human history. For a few hours, the world held its breath together. During the Apollo missions, astronauts placed corner reflectors on the lunar surface, arrays of mirrors designed to reflect laser beams sent from Earth. Scientists still use these today, firing lasers at the moon and timing how long they take to bounce back, measuring the moon's distance with centimeter precision. Before any human stepped on the moon, the Soviet Lunar 9 became the first spacecraft to successfully land on the lunar surface in 1966. It transmitted photographs back to Earth for 3 days. The space race to the moon was fiercely contested, and the Soviets achieved many milestones first. They just didn't get there with humans. Since the 1950s, more than 50 robotic spacecraft have been sent to the moon by various countries. They've orbited it, landed on it, crashed into it intentionally, roved across its surface, and carried the ashes of at least one scientist. The moon has been studied more intensely than any other world beyond Earth. The footprints left by Apollo astronauts are still there, and they'll remain pristine for millions of years. With no wind, no rain, no erosion, and only the slowest of micrometeorite impacts, the lunar surface changes almost imperceptibly. Those bootprints are a kind of fossil, imprints of the moment humanity first walked on another world. The 6 American flags planted by Apollo missions have almost certainly been bleached pure white by decades of intense solar radiation. Without an atmosphere to filter UV light, the flags would have degraded quickly. In a quiet irony, the symbols of American achievement on the moon now most likely look like flags of surrender. The moon is the final resting place of several spacecraft, deliberately crashed or intentionally impacted after their missions were complete. It also holds the cremated remains of geologist Eugene Shoemaker embedded in a lunar crater. He was the first human whose remains were placed on another world, a fitting tribute for someone who spent his life studying planetary impacts. Ancient astronomers mapped the moon using nothing but their eyes and careful observation over many years. The ancient Greeks calculated the moon's distance from Earth with remarkable accuracy using geometry. They knew the moon was a sphere. They understood eclipses. The moon has been humanity's first astronomical laboratory for thousands of years. In January 2019, China's Chang'e 4 mission made history by becoming the first spacecraft ever to land on the far side of the moon, a region that Earth-based radio signals cannot reach. A relay satellite positioned above the moon allowed communication. The rover Yutu too explored this never-before-visited terrain, sending back images of an alien landscape. In April 1970, an oxygen tank exploded aboard Apollo 13 on its way to the moon. The crew, Lovell, Hayes, and Swigert, had to abandon the command module and shelter in the tiny lunar lander, which was only designed for 2 people. Through improvised problem-solving and remarkable teamwork between the crew and mission control, they made it home safely after circling the moon. Apollo astronauts were allowed a small personal preference kit, a tiny bag of private items to carry to the moon. Astronauts brought family photos, medallions, mission patches from fallen colleagues, and other mementos. Neil Armstrong carried a piece of fabric from the Wright brothers' first airplane. Personal humanity traveled to the moon alongside scientific achievement. For centuries, the moon was essential to sea navigation. Sailors used a technique called lunar distance, measuring the angle between the moon and specific stars to determine their longitude at sea. The moon was a clock written in the sky, and understanding its position helped countless ships find their way across the vast, featureless ocean. Before Neil Armstrong's famous "one small step" quote, the very first words he spoke after landing on the moon were far more practical. As the Eagle touched down in the Sea of Tranquility, Armstrong said, "Houston, Tranquility Base here. The Eagle has landed." The response from Mission Control was equally understated. "Roger, Tranquility, we copy you on the ground." Hidden in the permanently shadowed craters near the moon's poles, where sunlight never reaches and temperatures drop to nearly -400 degrees Fahrenheit, there is water ice. It likely arrived billions of years ago, carried by comets and asteroids. This ice is one of the most precious resources the moon possesses. Future lunar bases might one day drink it, breathe it, and even use it as rocket fuel. The moon has what scientists call an exosphere, an incredibly thin layer of atoms skimming its surface. It's so thin that individual atoms rarely collide with each other. This lunar atmosphere contains sodium, potassium, argon, helium, and other elements, kicked up by solar wind and meteorite impacts. It's technically an atmosphere, but nothing you could ever breathe. Moon dust is not like the soft, rounded sand we find on Earth. Because there's no wind or water to erode it, lunar regolith is made of tiny, jagged, glass-like particles, sharp enough to cut and small enough to be breathed in. Apollo astronauts found it clung to everything and got into every crevice of their suits. For future lunar explorers, dust is one of the most serious health challenges to solve. Beneath the moon's surface lie vast underground tunnels, lava tubes formed when molten rock flowed through channels billions of years ago, and the outer crust hardened while lava drained out from inside. Some of these tubes may be miles wide and hundreds of miles long. They offer natural shelter from radiation and meteorite impacts, ideal locations for future human habitats. Just before lunar sunrise and after lunar sunset, there appears a faint glow on the horizon, a phenomenon observed by Apollo astronauts. It's caused by tiny dust particles levitated just above the surface by electrostatic forces from solar radiation. The moon quietly glows at its own edges, a soft halo of suspended dust floating in the silence. Near the lunar poles, the geometry of the moon's slight axial tilt means that the floors of some craters have never, not once in billions of years, received a single ray of direct sunlight. These permanently shadowed regions are among the coldest places in the entire solar system, colder even than the surface of Pluto. The Earth doesn't simply orbit the Sun. The Moon and Earth orbit each other, and together they both orbit a common center of gravity, called the barycenter. This point is actually located inside the Earth, about 1,000 miles beneath the surface, but it means Earth traces a slightly wobbly path through space, nudged by its companion. For centuries, astronomers have reported seeing brief flashes of light on the Moon, what scientists now call transient lunar phenomena. These mysterious glows, mists, and color changes have been recorded hundreds of times. The causes are still debated. Outgassing, electrostatic discharges, and meteorite impacts are all proposed explanations. The Moon still holds quiet, flickering secrets. During the Apollo 12 mission, when the ascent stage of the lunar module was deliberately crashed onto the Moon's surface, the entire Moon vibrated for over an hour. Scientists described it as ringing like a bell. This behavior suggests the Moon's interior is structured differently than Earth's, possibly drier and more rigid in ways that allow seismic waves to travel without being absorbed. The Moon has no global magnetic field today, unlike Earth's protective magnetosphere. But there are localized patches on the Moon's surface where the rock is strongly magnetized. Scientists believe these remnants date back to when the Moon had a global magnetic field billions of years ago. They may also explain why some regions of the Moon appear unusually bright. The magnetic fields deflected charged particles, reducing weathering. The South Pole Aitken Basin on the far side of the Moon is one of the largest and oldest impact craters in the solar system, about 1,600 miles across and nearly 5 miles deep. It's so large it barely looks like a crater from orbit, more like a vast, ancient wound. The material blasted up by the impact that created it may have scattered across the entire solar system. The solar wind has been depositing helium-3, a rare isotope, into the lunar surface for billions of years. Helium-3 is potentially a fuel for future fusion reactors. The Moon may contain enough helium-3 to power human civilization for thousands of years. It's one of the most tantalizing reasons some scientists and entrepreneurs dream of returning to the Moon at scale. About 1.4 billion years ago, the Moon was significantly closer to Earth, close enough that a day on Earth lasted only 18 hours, and lunar tides were dramatically more powerful. Ancient tidal patterns preserved in layered rock formations called tidal rhythmites record this vanished world, a time when the Moon loomed larger in the sky and the ocean surged with tremendous force. Because the Moon rotates so slowly, a lunar day from one sunrise to the next lasts about 29 Earth days. That means sunrise on the Moon is an event that unfolds over hours, not minutes. The sun crawls slowly above the horizon, while long shadows stretch for hundreds of miles across the ancient, silent plains. During a total lunar eclipse, the Moon turns a deep blood red, sometimes called a blood moon. This happens because Earth blocks direct sunlight from reaching the Moon, but some light is bent around Earth's edges by our atmosphere. The blue wavelengths scatter away, and only the warm red and orange light reaches the Moon's surface. Every lunar eclipse is a sunset viewed from the Moon. Across virtually every human culture throughout history, the Moon has been worshipped as a deity. In ancient Mesopotamia, the moon god Sin was one of the most powerful in the pantheon. The Egyptians had Thoth and Khonsu. The Greeks had Selene and Artemis. The Romans had Luna. Indigenous cultures around the world developed rich mythologies surrounding the Moon. For most of human history, the Moon wasn't a place, it was a presence. The very concept of a month comes from the Moon. The word month derives from moon. Ancient cultures tracked time by watching the Moon cycle through its phases, new moon to full moon and back, a period of about 29.5 days. Many calendars in use today, including the Islamic and Hebrew calendars, are still based on lunar cycles. Native American and early colonial traditions gave each full moon of the year a name, tied to the seasons and natural events. The wolf moon in January, the snow moon in February, the worm moon in March, the flower moon in May, the harvest moon in September or October. These names connected people to the rhythms of the natural world in a way that purely numerical calendars never quite could. Some of the oldest known artworks created by humans include depictions of the Moon. Cave paintings, carved bones with lunar notations, and ancient stone carvings suggest that observing and recording the Moon's cycles was one of humanity's earliest intellectual activities. Long before writing, before agriculture, before cities, humans were watching the Moon and marking its passage. The word lunatic literally means of the Moon. For centuries, people believed that the Moon, particularly the full moon, could cause madness, erratic behavior, and mood disturbances. The Roman goddess Luna was thought to afflict people with her influence. Though modern science doesn't support a strong link, the belief persisted so long it embedded itself permanently in language. Beethoven's Moonlight Sonata, Debussy's Clair de Lune, Van Gogh's Starry Night. The moon has drawn artists across every medium for thousands of years. There's something about its quiet, reliable presence, appearing night after night, changing yet constant, that speaks to the human heart. It's been a muse for as long as humans have made art. In many cultures, the moon's darker phases were associated with mystery, magic, and the supernatural. Witches cast spells by moonlight. Werewolves transformed under the full moon. The new moon, when the moon is invisible, was a time of hidden dangers and secret workings. The moon was both a gentle lantern in the night and a symbol of the unknowable. In Japan, the tradition of tsukimi, moon viewing, dates back over 1,000 years. In the autumn, when the moon is clear and bright, people gather to sit quietly and gaze at the moon, eating rice dumplings called tsukimi dango and celebrating the harvest. It is a practice of stillness, gratitude, and appreciation for the beauty of the natural world. Islam marks the start of Ramadan with the sighting of the new crescent moon. The Jewish calendar is lunisolar, tied to both moon and sun. The timing of Easter in Christianity is determined by the first Sunday after the first full moon following the spring equinox. The moon is woven into the fabric of religious time itself across much of the world. In 1865, Jules Verne wrote From the Earth to the Moon, a story about 3 men launched to the moon from Florida in a projectile fired from a giant cannon. A century before Apollo 11, Verne imagined a crew of 3, a launch from near Cape Canaveral, a journey of about 97 hours, and a splashdown in the ocean. The similarities to the actual Apollo missions are remarkable. The pattern of dark and light patches on the moon's surface has inspired pareidolia, the tendency to see faces and figures across cultures worldwide. Europeans saw a man in the moon. Chinese tradition sees a rabbit. In some South American cultures, it's a toad. Hawaiian mythology sees a woman named Hina. The same moon seen by different eyes becomes a different story. The moon appears in some of humanity's oldest written texts. Ancient Sumerian hymns to the moon god Sin date back over 4,000 years. The Epic of Gilgamesh references lunar observation. Ancient Egyptian astronomical texts record lunar cycles meticulously. The moon has been a subject of human writing for as long as humans have been writing. When Galileo turned his telescope to the moon in 1610 and saw craters and mountains, it shattered the ancient Greek idea that celestial bodies were perfect and unchanging. The moon was clearly a world with geography, with history, with scars. This was a radical, transformative idea, and the moon delivered it. The moon helped teach humanity how to think scientifically about the cosmos. For centuries, farmers across many cultures used the lunar cycle to guide their planting and harvesting. Root crops were planted during a waning moon. Above-ground crops went in during a waxing moon. Whether or not the science is fully supported, The practice connected agricultural communities to the rhythms of the sky in a deeply practical, daily way. Some scholars consider true history by the Greek writer Lucian of Samosata, written in the 2nd century AD, to be the first science fiction story. In it, a ship is carried by a great wind to the moon, where the sailors become embroiled in a war between the Moon King and the Sun King. Nearly 2,000 years ago, the moon was already the destination of humanity's imaginative journeys. Earth's seasons are caused by its 23.5-degree axial tilt. The moon's tilt is only about 1.5 degrees, barely any tilt at all. This means the moon has essentially no seasons. The poles receive very little sunlight year-round, and the equatorial regions stay consistently warm by day and bitterly cold by night, without the dramatic seasonal swings that Earth experiences. Without an atmosphere to regulate temperature, the moon swings between wild extremes. In direct sunlight, the surface reaches about 260 degrees Fahrenheit, hot enough to boil water. In the shadow, or on the night side, temperatures plunge to about -280 degrees Fahrenheit. These extremes occur just feet apart, separated only by the line of shadow. As the moon orbits Earth, it moves in and out of Earth's magnetic tail, the magnetosphere stretched out on the side of Earth away from the sun. Once a month for about 6 days, the moon passes through this magnetospheric tail. During this time, the moon is partially shielded from the solar wind, one of the only natural protections it receives from the constant flow of solar particles. The moon isn't a perfect sphere. Earth's gravity has distorted it slightly into an egg shape, with a slightly pointier end oriented toward Earth. Additionally, the moon's near side has a thinner crust than the far side, possibly a relic of its formation when the Earth-facing side was kept warmer by our planet's radiant heat during the moon's early molten years. Earth's magnetic field protects us from the solar wind, the constant stream of charged particles from the sun. The moon has no such protection. The solar wind bombards the lunar surface directly, slowly altering the chemistry of the rocks and implanting particles from the sun itself into the moon's outer layer. In a sense, the moon is slowly being painted by the sun. Lunar rocks brought back by Apollo contain several minerals that don't occur actually on Earth. Armalcolite, named after Armstrong, Aldrin and Collins, was first discovered in moon samples. Tranquilityite and pyroxferrite were also first found in lunar material. The moon has its own geological identity, a mineral profile shaped by billions of years of isolation in space. The moon's surface is littered with tiny glass beads formed when micrometeorites strike the lunar soil at tremendous speed. The heat of impact melts the rock, which flies upward and solidifies into small spheres as it cools in the vacuum of space. These glass beads are scattered everywhere, a record of billions of years of tiny, constant bombardment. The moon's gravity extends far beyond its surface. The moon is part of the Earth-Moon gravitational system, and together they influence the orbits of passing asteroids and comets. The moon's gravity has played a role in deflecting some near-Earth objects, possibly saving Earth from some impacts, though it has also redirected others toward us. The moon has no atmosphere, which means there is no medium for sound waves to travel through. If a boulder the size of a house crashed onto the moon's surface right next to you, a tremendous, violent impact, you would hear nothing. Absolute, total silence. The only sound on the moon would be vibrations conducted directly through your suit or boots, a world of complete acoustic emptiness. Because the moon rotates so slowly, one side faces the sun for about 2 weeks, while the other experiences 2 weeks of darkness. During the long lunar day, the surface bakes in intense, unfiltered sunlight. During the long lunar night, temperatures plunge to extreme cold. Future lunar habitats may be placed near the poles, where some locations receive nearly constant, gentle sunlight. The dark plains of the moon, the Maria, were created when giant asteroid impacts cracked the crust billions of years ago, allowing magma to flood upward and fill the craters. These ancient basins can be hundreds of miles across. The moon's geography was largely shaped not by slow geological processes, but by catastrophic violence from space. Due to Einstein's theory of relativity, time passes very slightly differently on the moon than on Earth. The moon's weaker gravity means that clocks on the moon tick ever so slightly faster than clocks on Earth by about 58.7 microseconds per day. This is a tiny difference, but it matters for precise navigation and communication systems. Even timekeeping must account for the moon's position in space-time. The lunar surface is scarred by billions of impact craters ranging from microscopic pits to vast basins hundreds of miles wide. Without erosion to erase them, every impact in lunar history has left a mark. Scientists can estimate the age of different regions by counting crater density. The more craters, the older the surface. The moon's face is a geological clock. Future lunar colonists may be able to build structures using the moon's own soil. Lunar regolith can be processed and sintered, heated to the point where it fuses together to create bricks and other building materials. 3D printing technologies are being developed to use regolith as a feedstock, potentially allowing robots to print lunar habitats before any humans even arrive. While water ice exists in permanently shadowed craters, the moon's surface has no liquid water. In the harsh conditions of direct sunlight and vacuum, any water would immediately evaporate and be lost to space. The ice that does exist has survived only because it has been kept in permanent shadow, never touched by direct sunlight, for billions of years. NASA's Artemis program aims to return humans to the moon, this time including the first woman and the first person of color to walk on the lunar surface. International partners, commercial companies, and space agencies around the world are collaborating on this effort. The moon is no longer just a destination of the past, it's the foundation of humanity's future in space. Many space agencies see the moon as an essential proving ground for the journey to Mars. By learning how to live and work on the moon, growing food, mining resources, managing long-duration missions, humanity can develop the skills and technologies needed to travel to the Red Planet. The moon is both a destination and a classroom. NASA and international partners plan to build a small space station called the Lunar Gateway, which will orbit the moon. It will serve as a staging point for missions to the lunar surface and eventually as a waypoint for deep space exploration. It would be the most distant crewed outpost in the history of space exploration, a small island of light far from Earth. Beyond its scientific and exploratory value, the Moon has genuine economic potential. Water ice at the poles could be converted into rocket fuel. Rare isotopes like helium-3 could be mined. Mineral resources present in lunar regolith could eventually be extracted. The Moon may become the first extraterrestrial economy, a place where resources are gathered, processed, and traded. For the first time in history, private companies, not just governments, are landing spacecraft on the Moon. Companies like Intuitive Machines, Astrobotic, and ISpace have developed lunar landers. The commercialization of the Moon is underway, opening the door to a future where lunar access isn't limited to superpowers, but is as routine as satellite launches. The lunar South Pole is rich in permanently shadowed craters containing water ice, and multiple nations are racing to explore and potentially claim access to these resources. China, the United States, India, and others have all expressed interest in this region. The Moon's South Pole may become one of the most geopolitically contested real estate in human history. Some scientists believe that ancient meteorite impacts may have ejected material from early Earth, potentially including primitive microorganisms, onto the Moon billions of years ago. While any such life would almost certainly not have survived, traces might theoretically remain preserved in the extreme cold of permanently shadowed regions. The Moon might hold fossilized echoes of early Earth life. The far side of the Moon, permanently shielded from Earth's radio emissions, would be an ideal location for a radio telescope. Without interference from human communications, it could detect faint signals from the early universe, the cosmic whispers of the Big Bang itself. A lunar radio telescope could open an entirely new window on the origin and history of the cosmos. As nations and companies send more missions to the Moon, a practical problem has emerged. What time is it on the Moon? Different missions use different reference times, creating potential coordination challenges. Efforts are underway to establish a coordinated lunar time, a standard timekeeping system for the Moon, just as Earth has Greenwich Mean Time. The Moon is civilizing itself, one time zone at a time. Some planetary scientists have proposed that early in solar system history, Earth may have had two moons. According to this hypothesis, the smaller companion moon eventually collided slowly with the larger moon, explaining why the lunar far side has a thicker crust than the near side. The Moon we see today may be the survivor of a gentle, ancient merger. The Moon is slowly drifting away from Earth, but this process won't continue forever. As Earth's rotation slows and eventually synchronizes with the Moon's orbital period, the tidal interaction will stop pulling the Moon outward. In the very distant future, billions of years from now, the Moon and Earth may settle into a final, stable, tidal lock with each other, always showing each other the same face. Humanity has left quite a lot of trash on the Moon: spent rocket stages, crashed landers, defunct rovers, seismometers, cameras, golf balls, and even bags of human waste left behind by Apollo crews. There are currently around 200 tons of man-made material on the Moon. The Moon bears the marks of our visits in a very literal sense. Though change is slow, the moon is not static. Micrometeorites rain down constantly, gradually churning the top layer of soil in a process called impact gardening. Solar wind particles chemically alter the surface over time. Occasional larger impacts blast fresh material across vast areas. The moon changes, just on timescales that make human history seem like the blink of an eye. When the sun expands into a red giant billions of years from now, Earth as we know it will be engulfed or scorched beyond recognition. But the moon, or what remains of it, may persist long after Earth's surface has been transformed. The moon, born from Earth's body, may silently outlast its parent, orbiting the dying embers of what was once our home. The moon has appeared in more films than almost any other astronomical object, from science fiction epics to romantic dramas to horror films. From Fritz Lang's 1929 silent film Frau im Mond to Stanley Kubrick's 2001 A Space Odyssey to recent films like First Man. The moon has been humanity's silver screen companion as long as there have been silver screens. From ancient Chinese poets contemplating the moon over a cup of wine to Keats and Shelley writing of moonlit nights, to Pablo Neruda and Rainer Maria Rilke, the moon has been the muse of poets across every language and tradition. Its quiet, distant light has made people feel wonder, longing, and a strange comfort in the face of the infinite. Long before human civilization, the moon rose and set over an empty earth. It rose over the first humans who ever looked up and wondered. It has accompanied every generation, every culture, every era of human history without exception. Whatever happens, wherever we go, the moon will be there, patient, ancient, and quietly lighting the way through the dark. Jupiter's enormous gravity acts as a shield, deflecting many incoming asteroids away from the inner solar system. But the moon also plays a role in Earth's defense. Its gravity can capture or redirect some objects that might otherwise strike Earth. We may have the moon to thank for surviving impacts that would otherwise have drastically altered or ended complex life on our planet. Light travels at 186,000 miles per second. The moon is about 240,000 miles away, which means that when you look at the moon, you're seeing it as it was about 1.3 seconds ago. It's a tiny journey back in time, but it's real. Every time you lift your eyes to the moon, you're witnessing the past. The universe is always a little older than what we see. We went to the moon once, and we will go again. It is written in who we are. The same curiosity that made our ancestors track the moon's phases, that made sailors navigate by its light, that made scientists and poets and dreamers look upward for thousands of years, that same restless, reaching spirit will carry us back. The moon is not just a place. It is a mirror of our deepest nature, always wondering, always reaching, always going just a little further into the night. The moon is about 384,400 kilometers away from Earth. That's so far that if you drove there at highway speed without stopping, the journey would take over 150 days. The moon is not perfectly round. It's shaped slightly like an egg, with the larger end pointing toward Earth. You'd never notice just by looking at it in the sky. A day on the moon, from one sunrise to the next, lasts about 29.5 Earth days. The sun rises slowly, climbs for 2 weeks, then takes another 2 weeks to set. The surface of the moon is covered in a fine, powdery layer of dust called regolith. It's made from billions of years of meteorite impacts grinding the rock down into something almost like talcum powder. That lunar dust smells. The Apollo astronauts described the smell of moon dust on their suits as something like gunpowder or burnt charcoal. A faint, ashy scent from a world with no air. The moon has no atmosphere to speak of. There's a very thin layer of gases, so thin it's called an exosphere, but it provides no protection from the sun, no weather, and no sound. It is completely, perfectly silent. Because there's no wind or rain on the moon, the footprints left by the Apollo astronauts are still there today. They'll likely remain for millions of years, undisturbed. The moon is slowly drifting away from Earth at about 3.8 centimeters per year. That's roughly the same rate your fingernails grow. In 1 billion years, it will be noticeably farther away. The same side of the moon always faces Earth. This is called tidal locking, and it happens because the moon's rotation and its orbit around Earth take exactly the same amount of time. We didn't see the far side of the moon until 1959, when a Soviet spacecraft called Lunar 3 photographed it for the first time. It looked almost nothing like the side we see, far fewer of the dark, smooth plains called Maria. The dark patches you see on the moon are called Maria, which is the Latin word for seas. Early astronomers thought they might be bodies of water. They're actually ancient lava plains, cooled and hardened billions of years ago. The brightest feature on the full moon is a crater called Tycho. It has long white streaks radiating outward caused by material ejected when an asteroid hit roughly 108 million years ago, around the time of the dinosaurs. The moon's gravity is about 1/6 of Earth's. That's why astronauts bounced when they walked on the surface. A person who weighs 180 pounds on Earth would weigh just 30 pounds on the moon. Despite the weaker gravity, the moon's gravity is strong enough to raise ocean tides on Earth. The oceans bulge slightly toward the moon, and as Earth rotates, those bulges move around the planet, creating the rhythm of high and low tides. The moon also creates tides in Earth's solid rock. The crust flexes by about 20 to 40 centimeters as the moon passes overhead, a slow, invisible breathing of the ground beneath your feet. The moon was most likely formed about 4.5 billion years ago when a Mars-sized object, sometimes called Theia, collided with the young Earth. The debris from that impact slowly clumped together in orbit and became the moon. Right after it formed, the moon was much closer to Earth, perhaps just 20,000 kilometers away. From Earth's surface, it would have looked enormous in the sky, more than 10 times wider than it appears today. The surface temperature on the Moon swings wildly. In sunlight, it can reach 127 degrees Celsius. In the dark, it can plunge to negative 173 degrees Celsius. No atmosphere means nothing to hold the heat in. Despite those extremes, scientists have found ice in permanently shadowed craters near the Moon's poles. These deep craters never see sunlight. The ice has been there, frozen in darkness, possibly for billions of years. The Moon has mountains. The lunar Apennine Range near the Apollo 15 landing site has peaks reaching over 5,000 meters high. They were formed not by tectonic activity, but by the shockwave of a massive ancient impact. The Moon is the fifth largest natural satellite in the solar system. But relative to the size of its planet, it's unusually large, larger in proportion than the moons of any other planet. A total solar eclipse happens because the Moon and the Sun appear almost exactly the same size in the sky, even though the Sun is about 400 times larger. It just so happens the Sun is also about 400 times farther away. This is an extraordinary coincidence. The Moon is moving away from Earth partly because of the energy transfer involved in the tides. The tidal bulges Earth creates actually pull the Moon forward in its orbit, slowly accelerating it outward. The Moon orbits Earth at about 3,683 kilometers per hour. That's fast enough to circle the Earth in about 11 hours, but its orbit is so large that it takes about 27 days to complete one full loop. There's a difference between the Moon's orbital period, 27.3 days, and the lunar month as we experience it, 29.5 days. The extra 2 days are because Earth is also moving around the Sun, so the Moon has to travel a little farther to get back to the same phase. Moonlight is not really light from the Moon. The Moon produces no light of its own. What you see is sunlight reflected off the lunar surface, and the Moon only reflects about 12% of the sunlight that hits it. Coal is actually darker than the lunar surface. If you put a piece of coal next to a chunk of lunar rock under the same light, the lunar rock would appear darker. The Moon only looks bright because it's surrounded by the darkness of space. The Moon has a very small, weak magnetic field, much weaker than Earth's. Scientists believe this is a remnant of an ancient magnetic field that existed when the Moon's core was still molten and active. The Moon has moonquakes. They're caused by tidal forces from Earth, meteorite impacts, and the thermal expansion and contraction of the surface as it heats and cools. Some moonquakes have lasted for over 10 minutes. The Moon's interior is layered. It has a thin crust, a mantle, and a small iron core at the center. The core is only about 350 kilometers across, tiny compared to Earth's core. When the moon is full and closest to Earth at the same time, it's called a supermoon. It can appear up to 14% larger and 30% brighter than a full moon at its farthest point. Still, most people can't tell the difference with the naked eye. A blue moon is the name given to the second full moon in a single calendar month. It happens roughly every 2.5 years because 12 full moons don't divide evenly into a 365-day year. Ancient cultures all over the world used the moon to keep time. The word month comes from the word moon. Many lunar calendars are still in use today, including those that determine the dates of Ramadan, Passover, and the Lunar New Year. The moon has no global tectonic plates like Earth does. Its surface has remained largely the same for billions of years, frozen in geological time, a preserved record of the early solar system. There are more than 300,000 craters wider than 1 kilometer on the moon's near side alone. Each one is a scar from an ancient collision, a record of billions of years of bombardment. The largest crater on the moon, the South Pole Aitken Basin, is about 2,500 kilometers wide and 8 kilometers deep. It's one of the largest impact craters in the entire solar system, and most of it is on the far side. The moon is geologically very old. Most of its surface rocks are between 3 and 4.5 billion years old. By comparison, it's very rare to find rocks on Earth older than 3 billion years. Neil Armstrong and Buzz Aldrin spent just over 2 hours walking on the lunar surface during Apollo 11. In that short time, they collected 21.5 kilograms of lunar rock and soil to bring back to Earth. In total, 12 human beings have walked on the moon, all of them American men, all between 1969 and 1972. No human has been to the moon since December 1972. The last person to walk on the moon was Gene Cernan, the commander of Apollo 17. Before climbing back into the lunar module, he paused, looked around, and quietly said goodbye. He never returned. Lunar rocks brought back by the Apollo missions have been given to countries and institutions all over the world. Some have been lost. A few have been stolen. One was given to the Netherlands, later discovered to be a piece of petrified wood, and no one is sure how the swap happened. The moon has very little water in its rocks compared to Earth. But water ice in shadowed polar craters means there may be enough to support future human explorers, a resource hiding in the coldest, darkest pockets of the lunar surface. During the Apollo 14 mission, astronaut Alan Shepard hit 2 golf balls on the moon with a makeshift club. He said the second one went miles and miles and miles. It was likely only a few hundred meters due to the suit restricting his swing, but in the moon's low gravity, it would have traveled much farther than on Earth. The moon has a feature called the lunar swirls, bright, swirling patterns on the surface, unlike anything seen elsewhere. They're associated with localized magnetic fields, but their origin is still not fully understood. Some of the moon's craters have human names. There's a crater named Lovell, one named Aldrin, one named Armstrong, and a small crater near the Apollo 11 landing site was named Little West by Neil Armstrong after a short walk he took on his own. The moon reflects so little sunlight that even the full moon is about 400,000 times dimmer than the sun. It's enough to cast faint shadows on Earth, but not enough to read by comfortably. Ancient Greek philosopher Anaxagoras in the 5th century BCE correctly proposed that the moon was a large rock and that it shone by reflected sunlight. He was ahead of his time by about 2,000 years. For a very long time, people believed the moon affected human behavior, that sleeping in moonlight could cause madness. The word lunatic comes from lunar, the Latin word for moon. Scientific studies have looked into whether the full moon affects human sleep, hospital admissions, or behavior. The evidence is mixed and generally weak, but the belief has persisted for thousands of years across many cultures. We're at the halfway point now. Take a slow breath if you need to. There's no hurry here. The moon has no seasons in the traditional sense. Because its axis is tilted only about 1.5 degrees compared to Earth's 23.5 degrees, the lunar poles receive almost permanent dim sunlight from a very low angle, and some craters are in permanent shadow. Billions of years ago, when the moon was volcanically active, vast amounts of lava poured out and flooded low-lying regions. As it cooled, it formed the smooth, dark plains we see today. That volcanic activity ended about 1 billion years ago. The moon has ancient lava tubes, underground tunnels left behind when the outer layer of lava cooled while molten rock continued flowing beneath. Some of these tubes are hundreds of meters wide and could potentially shelter future human habitats. The Soviet Union landed an unmanned rover on the moon in 1970. It was called Lunokhod-1 and traveled more than 10 kilometers across the lunar surface over 10 months. Scientists on Earth operated it remotely, driving it slowly across an alien world. Lunar eclipses happen when Earth passes directly between the Sun and the Moon, casting its shadow on the Moon. During a total lunar eclipse, the Moon can turn a deep reddish color, sometimes called a blood moon, because it's lit by sunlight filtered through Earth's atmosphere. Every sunrise and sunset on Earth turns red or orange because the atmosphere scatters blue light and lets red light through. During a lunar eclipse, all of Earth's sunrises and sunsets are projected onto the Moon at once, tinting it red. The Moon has very little seismic activity today. Those moonquakes are very mild compared to earthquakes. But during the first billion years or so, when the interior was still cooling and contracting, there may have been much more significant activity. Scientists can measure the exact distance to the moon using lasers. The Apollo astronauts left retroreflectors, small mirror arrays, on the surface. Researchers on Earth fire laser pulses at them and measure how long it takes for the light to return. That laser ranging experiment has been running for decades and has shown that the moon is not a perfect sphere, that it wobbles slightly in its orbit, and that it is indeed moving away from Earth by 3.8 centimeters per year. The moon has two broad types of terrain. The lighter, older, heavily cratered highlands called the terrae, and the darker, smoother, younger plains, the maria. The contrast between them is visible to the naked eye on any clear night. There's a mountain near the moon's south pole called Mons Malapert that sits in near constant sunlight because of the moon's minimal axial tilt. A solar panel placed there could theoretically receive sunlight nearly all the time. The moon was given many different names by different cultures. In Latin it is lunar. In Greek it is Selene. In Old English it was Mona, the same root that gives us the word Monday, which was originally Moon's Day. In many traditional cultures, the moon was associated with femininity, cycles, and the night. In others, it was masculine. The ancient Egyptians had a moon god called Khonsu. The Sumerians worshipped a moon god named Nana. The moon appears larger near the horizon than when it's high in the sky, but this is entirely an optical illusion. The moon is actually a tiny bit farther from you when it's on the horizon because you're viewing it from the Earth's surface rather than closer to Earth's center. If you held a coin at arm's length, you could block out the entire moon with it. The moon is extraordinarily far away, and while it's large, it looks tiny from the surface of Earth. The moon is the only other world in the solar system where humans have walked. Every other destination, Mars, Venus, Jupiter's moons, has only ever been visited by unmanned probes. The moon remains the single exception. One of the strangest things about the moon is that despite being so thoroughly studied, we still don't have complete answers to some basic questions, like exactly how much water ice is in those shadowed polar craters, or precisely when certain geological features formed. The astronauts of Apollo 8 were the first humans to see the far side of the moon with their own eyes in December 1968. They were also the first to photograph Earth rising above the lunar horizon, a moment that changed how humanity thought about its home planet. Apollo 8's Earthrise photograph, taken by astronaut William Anders, became one of the most reproduced photographs in history. It showed a small, fragile, colourful Earth hanging in the blackness of space, and the moon, barren and grey, in the foreground. The Moon has no global magnetic field to deflect solar wind, so its surface is constantly bombarded by charged particles from the Sun. Over billions of years, this has darkened and chemically altered the uppermost layer of the lunar soil. Lunar soil contains tiny glass beads formed when micrometeorites slam into the surface at tremendous speed, melting rock and flinging tiny droplets of molten material that cool almost instantly into glass in the airless environment. The Moon has been visited by more than 100 spacecraft from several countries. The United States, Soviet Union, Japan, China, India, and the European Space Agency have all sent missions. The Moon is humanity's most visited destination beyond Earth. China landed the Chang'e 4 spacecraft on the far side of the Moon in January 2019, the first time any mission had ever soft-landed on that side. It deployed a small rover called U-22 that has since driven several kilometers across the surface. India's Chandrayaan-3 mission successfully landed near the Moon's south pole in August 2023, making India only the 4th country to land a spacecraft on the Moon and the first to land at the South Polar region. The Moon's gravitational influence on Earth has gradually slowed Earth's rotation over billions of years. When the Moon first formed, an Earth day was only about 6 hours long. Tidal friction from the Moon has been slowing us down ever since. If the Moon disappeared tomorrow, the tides would weaken dramatically. They'd still exist because the Sun also exerts tidal forces, but they'd be much smaller. Over very long timescales, Earth's axis would also become less stable, leading to dramatic shifts in climate over millions of years. The Moon's stabilizing effect on Earth's axial tilt is one reason some scientists believe it may have contributed to the conditions that allowed complex life to develop on Earth, by preventing the extreme climate swings that would result from a wildly wobbling axis. Meteorites from the Moon have been found on Earth. When large impacts happen on the Moon, they can eject debris with enough force to escape lunar gravity, and some of that debris eventually falls to Earth. Dozens of confirmed lunar meteorites have been collected. The lunar surface has been shaped by a period called the Late Heavy Bombardment, roughly 3.9 billion years ago, when a surge of asteroids and comets struck the inner solar system. The Moon bears the scars of that violent time more visibly than any other body nearby, because it has no erosion to erase them. The Moon's crust is thicker on the far side than the near side by roughly 10 to 15 kilometers on average. One hypothesis is that the far side's crust solidified first when the early Moon's magma ocean cooled unevenly. Before the Apollo missions, there were serious scientific debates about whether the lunar surface was solid enough to stand on. Some researchers feared it might be covered in meters of loose dust that would swallow a spacecraft whole. It wasn't. When Apollo 11 landed, the landing legs pressed only slightly into the surface. The regolith was firm enough to walk on without sinking more than a couple of centimeters, a relief that was not entirely certain until the astronaut stepped out. The Moon has been in many ways a testing ground. The technologies developed for Apollo missions, everything from miniaturized computers to scratch-resistant lenses, have found their way into everyday life. There are several time capsules of sorts on the lunar surface. Besides the footprints and equipment left by the Apollo astronauts, there are also plaques, medallions, an olive branch, and a small aluminum sculpture called Fallen Astronaut, placed there to honor astronauts and cosmonauts who had died. The Moon passes through phases: new moon, crescent, quarter, gibbous, and full, based on how much of the sunlit side is visible from Earth. In any given month, every phase repeats in a steady, reliable rhythm. In many agricultural traditions, planting crops was timed to the phases of the moon: root vegetables during the waning moon, leafy plants during the waxing moon. The science behind this is disputed, but the practice has persisted for centuries. The Moon is not perfectly stationary relative to the stars. It moves eastward against the star background by about its own diameter every hour. Over a few nights, if you watch carefully, you can see it shift noticeably against the stars. The Moon has craters within craters within craters. Each major impact digs a new crater, sometimes overlapping older ones, creating a layered geological history that scientists can read like pages of a very old and battered book. Some craters on the Moon are named after scientists, philosophers, and artists. There are craters named after Copernicus, Kepler, Plato, Aristotle, Jules Verne, and many others, a quiet kind of immortality on a world where nothing erodes. The Moon's gravity affects not just Earth's oceans, but the behavior of groundwater. Tiny fluctuations in the water table have been measured in correlation with the Moon's position. Even deep underground, the Moon is present. The Moon has a cycle within a cycle. Every 18.6 years, the Moon completes a full wobble in its orbital plane relative to Earth's equator. This is called the Metonic cycle and was known to ancient astronomers who used it to predict eclipses. From the Moon's surface, Earth appears about 4 times larger than the Moon does from Earth. It hangs in the sky, blue and white, and slowly rotating, never rising or setting, because the Moon is tidally locked and Earth always sits in the same place in the lunar sky. The Moon has very old scars called rilles, long, narrow trenches or channels on the surface, some hundreds of kilometers long. They were likely formed by ancient volcanic activity, lava flows, or tectonic fracturing in the Moon's early geological past. The Moon has a very slight but measurable effect on the timing of rainwater and atmospheric pressure on Earth. These effects are tiny, almost negligible, but they show how deeply connected Earth and its Moon remain, even after billions of years. The moon is the only celestial body beyond Earth whose surface has been visited by humans. It is also the only place beyond Earth where human footprints exist, where human voices were once spoken aloud into the silence, however briefly. There are plans from multiple countries and space agencies to return humans to the moon in the coming years. If all goes well, the moon will once again feel the weight of human footsteps, and for the first time, humans who were not yet born when the last person left will stand on its surface. At the current rate of drift, in about 600 million years, the moon will be too far away to produce total solar eclipses. The moon will still be there, orbiting slowly in its widening path, but it will appear just slightly too small to cover the sun completely. In roughly 5 billion years, the sun will expand into a red giant and likely engulf the inner planets. The moon's fate is tied to Earth's. Both will be absorbed into the expanding star, returned to the elements that formed them, completing a very long, very slow circle. But that is an unimaginably long time from now. Tonight, the moon is right where it has always been, rising and setting, reflecting sunlight, pulling at the ocean steady and quiet above the sleeping world. The moon has watched over every human civilization that has ever existed. Every person who has ever looked up at the night sky has seen the same moon. Every lullaby sung in the dark, every wish made by moonlight, every quiet moment at the end of a long day, the moon has been there for all of it. It is ancient and it is still. And tonight, like every night, it is watching over you too. The moon is on average about 238,000 miles from Earth. That's far enough that all 7 of the other planets in our solar system could fit in the space between us and the moon, and there would still be room to spare. All that dark, quiet space between here and there. The moon travels around the Earth at roughly 2,288 miles per hour. And yet from here it looks perfectly, peacefully still. Sometimes things that are moving very fast appear to be standing completely still. A good reminder. It takes the moon about 27 days, 7 hours and 43 minutes to complete one full orbit around the Earth. Just over 27 days to circle all the way around and come back to where it started. The moon is the 5th largest natural satellite in our entire solar system. Out there among all the moons of Jupiter and Saturn and the other planets, our moon holds its own. Quietly. Reliably. 5th largest of them all. The moon is about 1/4 the size of Earth. If the Earth were the size of a basketball, the moon would be about the size of a tennis ball. 2 spheres floating together through the dark, one large and one smaller, turning slowly in the same gentle dance. The moon doesn't produce any light of its own. All that beautiful silver light you see on a clear night is sunlight, reflected back to you. The moon borrows the sun's warmth and sends it to you as something softer, something you can look at without looking away. Because the moon reflects sunlight, a full moon is actually about 14% brighter when it's closest to Earth in its orbit. A little more light on those nights. Just a little more luminous. The moon's surface reflects only about 12% of the sunlight that hits it. It's actually quite dark, as surfaces go. And yet, on a clear night, it fills the world with silver. 12% is enough, it turns out. 12% is beautiful. When you look at a full moon rising just above the horizon, it appears much larger than when it's high in the sky. But that's an optical illusion. The moon is exactly the same size. Your brain just perceives it differently when it's near familiar objects on the ground. The mind creates its own magic. On average, it would take about 3 days to reach the moon by spacecraft. The Apollo astronauts made that journey. 3 days of traveling through quiet, black, starlit space, and then the moon, waiting. The surface of the moon is covered in a layer of broken rock and dust called regolith. It's created by billions of years of meteorites striking the surface. Over billions of years, the moon has been slowly, quietly, turning rock into dust, dust all the way down. The lunar regolith is described as feeling like fine, dry sand, or talcum powder, soft and powdery. If you could reach out and touch the moon, it might feel like pressing your finger into something very soft. Like powder, like rest. There are mountains on the moon. Some of them rise nearly as high as mountains here on Earth. The Montes Apenninus range on the moon has peaks reaching over 18,000 feet. Mountains on the moon catching no wind, making no sound, standing in perfect silence forever. The moon has enormous flat plains called maria, from the Latin word for seas. Early astronomers looking through their first telescopes thought these dark, smooth regions might be actual bodies of water. They named them the Sea of Tranquility, the Sea of Serenity, the Ocean of Storms. Beautiful names for beautiful, quiet plains of ancient volcanic rock. The Sea of Tranquility, Mare Tranquillitatis, is where the Apollo 11 mission landed in 1969. The Sea of Tranquility. Even the name is peaceful. A sea of tranquility on the moon. The moon has no atmosphere, which means no wind. And no wind means that footprints left on the lunar surface will remain there for millions of years. Every footprint left by every astronaut is still there right now, perfectly preserved, as if the moon is holding on to them. The largest crater on the moon visible from Earth is called Bailey. It's about 300 kilometers wide. That's a bowl of ancient impact, sitting silent and still on the surface of the moon, large enough to hold most of France inside it. The Moon has over 300,000 craters wider than 1 kilometre. Each one is a record of something that collided with the Moon billions of years ago. The Moon keeps the memory of every impact, every one of them, recorded in stone. On the Moon, there is a place called the Oceanus Procellarum, the Ocean of Storms. It's the largest of the lunar maria, stretching about 2,500 kilometers across. A vast, ancient, utterly silent plain. The ocean of storms, perfectly still. The far side of the Moon, the side we never see, is more heavily cratered than the near side. It looks different. Rougher, more ancient. It has never once faced the Earth in all the billions of years of the Moon's existence. That side is its own private place. During a lunar day, temperatures on the Moon's surface can reach 260 degrees Fahrenheit. During a lunar night, they can drop to negative 280 degrees, without an atmosphere to hold any warmth. Heat comes and goes like a passing dream. A single day on the Moon, from one sunrise to the next, lasts about 29.5 Earth days. The sun rises slowly, moves slowly across the sky, and sets slowly. And then the long, long night begins. Because the Moon has no atmosphere, there is no sound on the Moon. None at all. No wind. No rustling. No distant hum. Complete and absolute silence. The astronauts could only hear each other through a radio. The Moon is the quietest place we've ever visited. The Moon has no weather. No clouds drift across its surface. No rain falls. No snow. No storms. Just that long, slow rotation in the dark and the light, utterly peaceful, utterly still. In permanently shadowed craters near the Moon's poles, temperatures may never rise above negative 240 degrees Celsius. These are among the coldest places in the entire solar system. Ancient cold. Undisturbed for billions of years. The Moon has almost no magnetic field. Earth's magnetic field is what creates the northern lights and protects us from solar wind. The Moon, without one, simply receives the solar wind directly, quietly, openly. It holds nothing back. Scientists have detected water ice in the shadowed craters near the Moon's south pole. Water on the Moon. Ancient ice tucked away in the dark, cold shadows, untouched for perhaps billions of years. The gravity on the Moon is about 1/6 that of Earth. On the Moon, you would weigh about 1/6 of what you weigh here. You could jump 6 times as high. Walking there means floating, almost. Bounding slowly in the soft, low gravity like something from a dream. Moonquakes are a real phenomenon. The Moon occasionally shakes very gently due to gravitational forces from Earth and the Sun, or from meteorite impacts. but they are slow, shallow, gentle tremors. The moon breathes in its own quiet way. Because there is no atmosphere on the moon, the sky above the lunar surface is completely black, even during the day. Stand on the moon with the sun blazing overhead, and the sky behind it would be dark as night. Stars and sun together, day and night at once. The moon is slowly moving away from Earth at a rate of about 3.8 centimeters per year. That's roughly the rate at which your fingernails grow. Imperceptibly, gently, year by year, the moon is inching a little farther away. But it will be doing so for billions of years still to come. The moon's gravity is what causes Earth's ocean tides. As the moon orbits us, it pulls the oceans very slightly toward it. Every tide that has ever washed ashore, every wave that has ever smoothed a stone, shaped by the moon. Quietly, continuously. The moon helps stabilize Earth's axial tilt. Without the moon, Earth's tilt might wobble dramatically over time, changing climates radically. The moon holds us steady. It has been keeping Earth's axis stable, and therefore keeping our seasons regular for billions of years. Scientists believe the moon formed about 4.5 billion years ago when a Mars-sized body collided with the early Earth. The debris from that enormous collision gradually gathered together, pulled by gravity, and became the moon. It was born of fire and collision, and now it is the most peaceful thing in our sky. The moon is tidally locked to Earth, which means the same side always faces us. It rotates exactly once on its own axis for every orbit it makes around Earth. A perfect, synchronized dance. The moon always shows us the same face. Always. The gravitational pull between the Earth and the moon also very slightly slows Earth's rotation over time. Days on Earth were once shorter. 4 billion years ago, a day on Earth lasted only about 6 hours. The moon has been gently, almost imperceptibly, lengthening our days ever since. The moon has a small but measurable effect on Earth's atmosphere, a kind of atmospheric tide, similar to the ocean tides. Every full moon and new moon, our air itself rises and falls just a tiny bit. The moon touches even the air we breathe. A solar eclipse happens when the moon passes directly between the Earth and the Sun. Remarkably, the moon is about 400 times smaller than the Sun, but also about 400 times closer, so from Earth, they appear almost exactly the same size. This cosmic coincidence lets the moon perfectly cover the Sun. A coincidence in the billions. A perfect fit. The near side of the moon, the side we always see, has a thinner crust than the far side. The Earth's gravity has subtly shaped even the interior of the moon over billions of years. They have shaped each other, these two, in the long, quiet conversation of gravity. Earth and the Moon are sometimes described as a double-planet system because the Moon is so large relative to Earth compared to other planet-moon pairs. We are not just a planet with a moon. We are, in some ways, two worlds traveling together. Ancient Babylonian astronomers were tracking the moon's cycles as far back as 5,000 years ago. They built their calendars around it. They named its phases. The same moon you see tonight was being watched, noted, and recorded 5,000 years ago. The word month comes from the word moon. A month was originally the time it takes for the moon to complete one cycle of phases, from new moon to new moon. Every time you say the word month, you're saying moon. Many ancient cultures around the world used lunar calendars. The Islamic calendar is still purely lunar today. So is the Hebrew calendar. The Chinese calendar uses a lunisolar system. Billions of people still organize their sacred time around the movements of the moon. Galileo was among the first to turn a telescope toward the moon in 1609. He saw the mountains and craters and was amazed. For the first time, a human being looked at the moon and saw a landscape, a world, rather than just a light in the sky. The first spacecraft to reach the moon was the Soviet Lunar 2 in 1959. It didn't land, it impacted the surface. But for the first time, something made by human hands touched the moon. A small piece of Earth arriving on the moon more than 60 years ago. The first photographs of the moon's far side were taken by the Soviet Lunar 3 spacecraft in 1959. For the first time, human beings got to see the side of the moon that had never faced Earth. The hidden side revealed at last. "12 human beings have walked on the moon, all of them American, all between 1969 and 1972. 12 people who stood in that low gravity, in that perfect silence, and looked up at the Earth hanging in the black sky. Neil Armstrong became the first person to walk on the moon on July 20th, 1969. He stepped out of the lunar module at 10:56 p.m. Eastern Time. Much of the world stayed awake to watch. A moment when the whole Earth held its breath together. The Apollo astronauts brought back a total of about 842 pounds of lunar rock and soil. Those samples have been studied ever since. They have told us more about the history of our solar system than almost anything else we've ever collected. The last person to walk on the moon was Gene Cernan on December 14th, 1972. Before climbing back into the lunar module, he paused and looked around at the silent, still surface. He was the last. And as of tonight, more than 50 years later, no human has been back. How is your body feeling right now? Notice if you've been holding any tension somewhere, and let it go. Let your hands soften. Let your breathing slow, just a little more. The moon is out there right now, or on the other side of the world, rising over some quiet ocean or setting behind some distant mountains. It has been rising and setting for 4.5 billion years. You are held tonight by a very old world. Let's continue. The dark patches you can see on the full moon with your naked eye are the ancient lava plains, the Maria. They're darker because basalt rock is darker than the surrounding highlands. You can see the history of ancient volcanic eruptions just by looking up. The moon has a feature called Tycho crater that has bright streaks radiating out from it, called rays, that you can see from Earth with the naked eye. These rays are material that was thrown outward when the crater was formed about 108 million years ago. A starburst, frozen in stone. A supermoon occurs when a full moon coincides with the moon being at its closest point to Earth in its elliptical orbit, called perigee. At perigee, the moon can appear up to 14% larger and 30% brighter than at its farthest point. A little closer, a little more luminous. A micromoon is the opposite, a full moon that occurs when the moon is at its farthest point from Earth, called apogee. It looks smaller and dimmer. The same moon, just a little farther away. Still faithful, still rising. A blue moon is a term for the second full moon in a single calendar month. It happens roughly every 2 to 3 years. Once in a blue moon, meaning rarely, something special, comes from this phenomenon. Special because it's rare. Worth noticing. During a lunar eclipse, when Earth's shadow falls across the moon can turn a deep, glowing red-orange color. This is sometimes called a blood moon. The color comes from sunlight, bending through Earth's atmosphere and falling on the moon, every sunrise and sunset on Earth all at once, painting the moon red. The moon's phases, new moon, crescent, quarter, gibbous, full, repeat on a cycle of about 29.5 days. That's the synodic month. Every 29.5 days, the moon completes its cycle of light and shadow. Reliable as breathing. When you see a crescent moon just after sunset, the faint glow you can sometimes see on the dark part of the moon is called earthshine. It's sunlight reflected off Earth, bouncing onto the moon's surface. Earth lighting up the moon giving it back to you. In some cultures, the pattern of light and dark on the full moon is seen as a face, the man in the moon. In others, it is a rabbit. In others, a toad, or a woman, or a moose. The same patterns of light and shadow, read differently by different eyes across all of human history. When the moon is near the horizon, the atmosphere filters its light and it can appear orange or yellow. On nights when there is dust or smoke in the air, the moon can glow in rich amber shades, warm as candlelight. Take a breath in and slowly let it out. You've just traveled through 100 quiet little truths about the moon. Facts that have existed long before you were born and will remain long after. The same moon the ancient world looked up at is the same one watching over you tonight. It doesn't rush, it doesn't worry, it simply rises and sets and rises again. A rhythm as old as time itself. Let your body feel heavy now. Let your thoughts grow soft and slow, like moonlight spreading across still water. You don't need to hold on to anything tonight. The moon will keep watch. If you'd like more moments like this one, everything you need is just below. Subscribe so the next one finds you right at the edge of sleep. Until then, rest well.